Double-decker buses have long been a fixture on the streets of London, England. A typical double-decker carries 60% more riders than a regular bus. And though quintessentially British, nowadays you'll find London-style double-deckers on the streets of several major cities throughout the world. Every bus design undergoes rigorous stability testing. They fill the prototype with lead weights to simulate a full passenger load, then tip the bus to a 28-degree angle, the side wheels lifting about shoulder height off the ground. If the vehicle doesn't keel over, the design passes the test. The bus's underframe, the chassis, is made of welded steel. They construct it in 3 separate modules, front, center, and rear, then set the 3 modules in an alignment jig to be welded together. Once that's done, welders add a steel structure that'll support the floors, seats, and body panels. They clean the chassis and paint it with an anti-rust epoxy. After baking on the paint, they seal the gaps between the welded parts with polyurethane. This prevents water penetration, which would cause internal corrosion. Meanwhile, technicians bolt the 6-cylinder 250 horsepower engine to the automatic transmission and connect the hydraulic lines and other piping. Then they wheel this engine pack over to the assembly line and bolt it to a bar at the rear of the chassis. By suspending the engine, they shield it from impact damage in the event of a rear-end collision. They also install the radiator, battery, and other components. At the front of the chassis, they install the driver's binnacle, on which all the controls are located. Unlike a stationary car dashboard, for driver comfort, the binnacle tilts with the steering column. After installing the front and rear axles, technicians mount the wheels. Each one is more than 1 meter in diameter and weighs 45 kilograms. The engineering specs require the wheel nuts to be turned to a specific tightness. Workers also install the driver's seat and the vehicle's 275-liter gas tank. The complete chassis goes onto a test drive machine, which simulates varying passenger loads and road conditions. A camera pointed at the binnacle records the accuracy of the speedometer and whether any warning lights illuminate. Then it's into the body shop, where workers mount fiberglass boxes over the wheels. Another team builds the interdeck floor, the aluminum frame structure that separates the bus's 2 levels. They affix the lower level's melamine ceiling to one side and the upper deck's plywood floor to the other. To make the roof, they construct an aluminum frame, then glue an aluminum sheet onto it. Most of the bus's body is made of aluminum because, compared to other metals, it's lightweight, durable, and easy to repair. Next, they paint the roof and install components integrated within it, such as the aerial antenna and wires for lighting. As this computer animation illustrates, step by step, the bus is slowly taking shape. Workers insert the pegs underneath the roof into aluminum pillars running the perimeter of the upper deck. Along the sides, workers sandwich the structural frame between inner and outer aluminum body panels. First, they affix the inner ones. Then they fill the spaces in between with blocks of foam insulation. Finally, they glue on the outer side panels, pressing out the excess adhesive with a roller so that the panel lays flat. The front and back of the bus are made of molded fiberglass. They have openings for windows, and in the back, a cutout beneath the top window for the upper deck air conditioner. As one crew glues all the window glass into place, others install the doors, and inside, the upholstered seats and a durable, non-slip floor covering. Once the bus comes back from the paint shop, the factory's quality control department inspects the interior. The seat fabric is dark and patterned to discourage graffiti. The bus also has 12 cameras hidden in various locations to deter vandalism. The typical double-decker is 10 meters long and nearly 4.5 meters high. It carries up to 92 passengers.